Good morning, students. Unit 5, Alkali and Alkaline Earth Metals. Alkali and Alkaline Earth Metals. In this session, I am going to teach the Alkaline Earth Metals, the general characteristics of Alkaline Earth Metals. The periodic table, in modern periodic table, contains 18 groups. Contains 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, in modern periodic table contain 18 groups and 7 periods. First period, second period, third period, fourth, fifth, sixth and seventh. Right? 1, 2, 3, 4, 5, 6, 7. 7 periods and 18 groups. Right? In first 2 groups called S block elements. In last 6 groups called P block elements. And middle 10 groups are called D block elements. Are you right? So transient elements. Alright? The first group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium are called alkali metals. And second group elements, beryllium, magnesium, calcium, strontium, barium and radium. So are called alkaline earth metals. Right? The alkaline earth metals found in the second group in periodic table. The position of periodic table in second group. You right? So beryllium, magnesium, calcium, strontium, barium and radium. Okay, so these elements are called alkaline earth metals. They except beryllium. Right? They except beryllium. All other elements are called alkaline in nature. Because the magnesium, calcium, strontium, barium oxides and hydroxides are alkaline in nature. Okay, so except beryllium, in others, all elements are commonly called alkaline earth metals. Are you right? So magnesium oxide and magnesium hydroxides dissolve in water. So in basic in nature, right? Except beryllium. Why? The beryllium hydroxide. A beryllium hydroxide is amphoteric in nature. The beryllium hydroxide is amphoteric in nature. So both acidic and basic character contain hydroxides. So except beryllium. In all other elements of oxides and hydroxides are commonly called alkaline earth metals. Okay. So magnesium, calcium, strontium, barium oxide and hydroxide is alkaline in nature. Do you right? So the magnesium oxide except beryllium, the other metal oxides found in earth crust. Found in earth crust. Right? Right. Elements. Beryllium. The abundance in earth crust by weight. Parts per million. ppm level. The weight parts per million. Right? Mineral source. Beryllium. Okay. 2 ppm. Abundance in earth crust. Okay. Beryl. Beryllium 3, aluminum 2, silicon 6, oxygen 18. Okay. So the magnesium 27,640. 27,640 pico parts per picometer presence in abundance in earth crust. Okay. So the minerals of magnesium, mineral source of magnesium, cornellite, potassium chloride dot magnesium chloride 6H2O. Dolomite, magnesium carbonate and calcium carbonate. The calcium 1.84 parts per picometers. Okay, the mineral source fluorabadite, calcium 5, phosphate 3, F, fluorabadite. Right? Next, strontium. The strontium 384 parts per picometers. Celestite, strontium sulfate. The mineral name celestite. Right? Barium 390 picometer parts per picometer. So barytes, barium sulfate, barytes. Right? Okay, students. The general characteristics of alkaline earth metals. The general characteristics of alkaline earth metals. The first one is physical state. Physical state. The beryllium is rare. And radium is the rarest of the all, comprising only 10% of igneous rocks. So வெப்ப பாறைகள்ல 10% மட்டும்தான் இந்த பெர்லியமும் ரேடியமும் கிடைக்கும். அதனால தான் பெர்லியம் ரேர். Radium is a radioactive element. So rarest, beryllium and radium. Alright. Next, the magnesium and calcium. The magnesium and calcium are very common in the earth crust. earth crust கிடைக்கக்கூடியது. The found in many rocks. நிறைய பாறைகளிலும் and minerals தாதுக்கள்லையும் காணப்படக்கூடியது. Okay, so கனிமங்கள்லையும் காணப்படக்கூடியது. Right? The magnesium is the 18th most abundant element. Magnesium is the 18th most abundant element. Calcium is the 5th most abundant element. You right? Okay, so the magnesium in cornellite. The minerals of magnesium, cornellite. Right? Cornellite, potassium chloride, magnesium chloride, and 6H2O. It's a cornellite. Magnesite, magnesium carbonate. The mineral of magnesium carbonates are called magnesite. Dolomite, magnesium carbonate and calcium carbonate. Okay, so the minerals of magnesium carbonate, magnesite and dolomite. Right? The minerals of calcium, chalk, limestone, gypsum and blue john. Okay, the calcium fluoride. Calcium fluorides are called blue john. So one more question. Okay, so which one of the following minerals are called blue john? Calcium fluoride. CaF2 are called blue john. Are you right? So the next, strontium. So the minerals of strontium, celestite, strontium sulfate, it's called celestite, and strontianite, strontianite, okay, strontium carbonate. The mineral name Strontium carbonate is a strontianite. Next, barium. The barium is a slightly less common element. Okay, the mineral of barium, barite. The barium sulfide mineral name, barite. Radium. So being a decay product. The decay product of uranium. Okay, uranium is a radioactivity element that occur in radio decay to produce the radium elements. Right? Is found in all uranium bearing ores. Uranium bearing ores. Uranium இருக்கக்கூடிய எல்லா ஓர்லயும் ரேடியமும் இருக்கும். Right? So the next one is electronic configuration of alkaline earth metals. The alkaline earth metals: beryllium, magnesium, calcium, strontium, barium, radium. Okay, so in a periodic table, the first period contain 2 elements. The second and third period contain 8 elements, and fourth and fifth contain 18 elements, and sixth and seventh contain 32 elements. Okay, the beryllium presents in second periods. So atomic number 4. So the beryllium and magnesium difference between 8 elements. Okay, so add 8, so 12. So difference 8. Okay, 12. Right? The second and third difference 8. And third and fourth also difference 8. So 20. Friends, 20. Atomic number 20. And calcium and strontium difference 18. Okay, so 38. Difference 18. Okay, so 38. And strontium and barium difference 18. Okay, so 56. Difference 18. Okay, 8 plus 8, 16, 6, remaining 1, 56. And radium and barium difference 32. So 88, 32. Okay, 88. Difference 32. Do you right? So the atomic number of alkaline earth metals: beryllium 4, magnesium 12, calcium 20, strontium 38, barium 56, and radium 88. Electronic configurations. Okay, so noble gas: helium, neon, argon, krypton, xenon, and radon. Okay, so the second row 2s2, third row 3s2, in fourth period 4s2, fifth period 5s2, sixth period 6s2, and seventh period 7s2. Thus all the elements contain 2 electron in valence cell. The preceded by the noble gas electronic configuration. Noble gas electronic configuration அப்புறம் வேலன்ஸ்ல 2 எலக்ட்ரான் இருக்கும். அதனால இதனுடைய ஜெனரல் electronic configuration. The general electronic configuration of alkaline earth metal, noble gas electronic configuration. The preceded by the noble gas electronic configuration. Okay, NS2. The N represents the valence. Cell. You right? So the common electronic configuration of alkaline earth metal NS2. Okay, so preceded by the noble gas electronic configuration. Okay, students. The next general characteristics of alkaline earth metal is atomic and ionic radii. Atomic and ionic radii. Atomic and ionic radii. Already you know that the define atomic and ionic radii. The distance between the center of the nucleus. The distance between the center of its nucleus and the valence cell electron. The valence cell contain electron. Okay, so the distance between the center of its nucleus and the valence cell electron, valence cell contain electron is called atomic or ionic radii. Right? So magnesium is atomic radii, magnesium 2 plus ionic radii. Ionic radii. Right? So the magnesium 2A2, 2A2 and magnesium 2 plus 2A8. 2A8. Okay, the atomic radius of magnesium is greater than an ionic radii of magnesium. Okay, so the cationic radius is less than neutral atom. Less than neutral atom. Right? So in alkaline earth metals, beryllium, magnesium, calcium, magnesium, calcium, strontium, barium and radium. Okay, so the atomic and ionic radii of alkaline earth metals. Okay, in second group element, the first group element, lithium, sodium, potassium, rubidium, cesium and francium. Okay, atomic number beryllium 4, 12, right, 20, 38, 50, 56. Okay, so 8, difference 18. Okay, 8, 16, 32, 88. Right? So lithium 3, sodium 11, potassium 19, 37 rubidium, 55 cesium and 87 francium. Okay. The lithium 3, beryllium 4. The nuclear charge increases. The alkaline earth metals nuclear charge increases than alkali metals. Okay, so lithium 2, 1, but in beryllium 2, 2, 2, 2. Okay, so the atomic and ionic radii of alkaline, the alkaline earth metals, the atomic and ionic radii of alkaline earth metals is less than alkali metals. Alright, so because the nuclear charge increases, the nuclear charge of lithium 3, the nuclear charge of beryllium 4, the nuclear charge increases, the effective nuclear charge, the attractive force between the nucleus and electron is more. Effective nuclear charge increases. The screening effect decreases. But nuclear charge increases. So the size decreases. So alkaline earth metals, the atomic and ionic radii is less than alkali metals. Are you right? So in top to bottom, beryllium contain 2 cells, but magnesium contain 3 cells. Okay, so calcium contain 4 cells. Strontium contain 5 cells. 5 cells. So increasing the atomic and ionic radii to top to bottom in group. Okay, so to increases the gradual increase of new cell. The gradual increase of new cell in top to bottom. The valence electron ended to new cell. The screening effect is increases. The inner electron is increases. The screening effect are also increases. The effective nuclear charge is decreases to top to bottom. The effective nuclear charge is decreases. The screening effect is increases. The size increases. From top to bottom, the size is increases. The atomic and ionic radii is increases. Are you right? So top to bottom, atomic and ionic radii is increases. Okay, so next, the common oxidation state of alkali metals. The common oxidation state of alkali metals. Alkaline earth metals. The common oxidation state of alkaline earth metals. Right? So in alkaline earth metals, the valence electron, all the alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, radium, in all the alkaline earth metals, so beryllium, the valence electron 2s2, magnesium 3s2, calcium 4s2, and strontium 5s2, and barium 6s2, and radium 7s2. In all the alkaline earth metals contain the 2 electron in valence shell, preceded by the noble gas electronic configuration helium, neon, argon, krypton, xenon, radon. Okay, so all the alkaline earth metals easily loss of 2 electron. Easily loss of 2 electron to reach noble gas electronic configuration, beryllium, helium. Okay, so magnesium, neon electronic configuration, and calcium rich argon electronic configurations, and strontium rich krypton electronic configuration, and barium rich xenon electronic configuration, and radon rich. Okay, so helium, neon, argon, krypton, xenon, the radium rich radon electronic configuration. So easily loss of 2 electrons to reach noble gas electronic configuration. So the common oxidation state of alkaline earth metal is +2. The common oxidation state of alkaline earth metal is +2. You right? The next, the ionization enthalpy. The next, ionization enthalpy. Ionization enthalpy or ionization potential or ionization energy. Okay, so define ionization energy. Define ionization energy. Okay. For example, magnesium 2A2. The minimum amount of energy. The minimum amount of energy required. The minimum amount of energy required to remove the loosely bounded the valence electron in gaseous state. Magnesium is a gaseous state. Okay, so to remove the loosely bounded electron to reach magnesium plus. Okay, so plus 738 kilojoule mole inverse ionization enthalpy or ionization energy, right? So the minimum amount of energy required to remove the loosely bounded valence electron in gaseous atom at ground state electronic configuration. Okay, is the ionization enthalpy. Ionization enthalpy in a periodic table in left to right in period, the size is decreases. In left to right period, the size is decreases. The effective nuclear charge is increases. The nuclear charge is increases. So the force of attraction between the nucleus and electron is more. The size is decreases. The ionization energy or ionization enthalpy increases from left to right. So in p block elements, so more ionization energy. P block element is more ionization energy. The S block element is less ionization energy. Are you right? So the ionization energy of alkaline earth metal. The ionization energy of alkaline earth metal is less than p block elements. You write the smaller size in p block element than alkaline earth metals. So ionization energy is higher in p block elements. In alkaline earth metal, this ionization energy is least. Okay, to compare to alkali and alkaline earth metals. Sodium, potassium, rubidium. Okay, so lithium, sodium, potassium, rubidium, cesium and francium. Okay, so alkali metals and alkaline earth metals. Alkaline earth metals, beryllium, okay, magnesium, calcium, strontium, barium and radium. Okay, so for example, sodium and magnesium. The ionization enthalpy of alkaline earth metals. Is higher than alkali metals. Already you know that the alkaline earth metal size is lesser than alkali metals. Okay, the sodium size, but in magnesium size small. In all the alkaline earth metals, size is smaller than alkali metals, corresponding alkali metals. Okay, so ionization enthalpy is higher in alkali earth metals than alkali metals. Right? But in electropositive nature, the electropositive nature is lesser than alkali metal. The size is larger size, so easily loss of one electron to reach noble gas electronic configuration. For example, sodium 11, the loss of one electron to 8 in one electron. So easily loss of one electron to reach Na plus, the larger size, so easily loss of an electron. But in magnesium 2, 8, 2. Okay, so size is smaller than alkali metals. The effective nuclear charge increases. So the more energy having removal of one electron than alkali metals. You right? So the ionization enthalpy in alkaline earth metal is higher than alkali metals, but in electropositive nature, electropositive nature, alkali and alkaline. Okay, so alkali and alkaline earth metals. Alkali metals, alkaline earth metals. The electropositive nature is higher in alkali metals. Okay, the first ionization energy. The first ionization energy is alkali and alkaline earth metals. Alkali and alkaline earth metals. The first ionization energy is higher in alkaline earth metals than alkali metals. Right? So the size decreases. The effective nuclear charge is increases. The effective nuclear charge is increases. Okay, so the screening constant is decreases. Right? The size is decreases. The ionization energy are also increases in alkaline earth metals. In top to bottom, the size is increases. The extra electron added to new cell. The screening effect is increases. The inner electron cell is increases. The screening effect are also increases. The effective nuclear charge is decreases. So ionization energy are also decreases in top to bottom in alkaline earth metals. But the second ionization energy, the alkali and alkaline earth metals. The second ionization energy is less than. The second ionization energy of alkaline earth metal is less than alkali metals. The second ionization is more in alkali metals. Okay, the reason, for example, sodium Na, atomic number 11, 2,8,1. Okay, the first ionization energy value of sodium 495 kilojoule mole inverse. Right? So Na is converted to Na plus, loss of 1 electron, the electronic configuration 2,8. Okay, loss of marriage. The alkali metals, loss of 1 electron to reach noble gas electronic configuration, neon electronic configuration, is a more stable ion. Na plus ion is a more stable. But first ionization energy of magnesium Mg12 2,8,2. Right? So the first ionization energy will give Mg plus loss of 1 electron. Okay, the first ionization energy of magnesium 738 kilojoule mole inverse. Right? So electronic configuration 2,8,1. The first ionization energy is higher in alkaline earth metals than alkali metals. Magnesium is an alkaline earth metals, right? The first ionization energy value 738 kilojoule mole inverse. First in sodium alkali metals, the first ionization energy 495 kilojoule mole inverse. Do you right? So the nuclear charge is increases. Nuclear charge 11, nuclear charge 12. The nuclear charge is increases. The effective nuclear charge increases. Size is decreases. So ionization energy are also increases. Do you right? The first ionization energy, okay, the alkaline earth metal is higher than alkali metal. But in second ionization energy, the second ionization energy of alkali metal, for example, sodium Na plus. The electronic configuration 2,8. The more stable Na plus ions due to rich noble gas neon electronic configurations. Okay, so loss of electron in ionization energy 2 to Na2 plus, loss of 1 electron. The second ionization energy 4,562 kilojoule mole inverse. Okay, and magnesium Mg plus. Okay, so electronic configuration 2,7. So magnesium 2,8,1. Magnesium plus 2,8,1. So second ionization energy, right? So Mg2 plus to reach stable electronic configuration 2,8 plus loss of 1 electron. Right? The second ionization energy 1450 kilojoule mole inverse. Okay, so the second ionization energy alkaline earth metals, for example magnesium 1450 kilojoule mole inverse. But in second ionization energy of alkali metal sodium 4562 kilojoule mole inverse. Okay, so the second ionization energy of alkali metals. So alkali metals already reach noble gas electronic configuration, more stable. So more energy required to remove one more electron in cation. Are you right? But in alkaline earth metals, okay, the cations contain valence 1 electron. Already loss of 1 electron, left one more electron in cation. Alright, thus cation loss of 1 electron to easily then the cation of alkali metals. The cation of alkali metals. Okay, so alkaline earth metals ions, the valence electron left 1. So easily loss of 1 electron. Are you right? So the second ionization energy of alkaline earth metal is lesser than alkali metals. Do you understand? Okay. Right. Okay, students. The next characteristics of alkaline earth metals: hydration. The hydration enthalpies. Alkali metals and alkaline earth metals. Okay, so alkali metals large size, but alkaline earth metals compared to alkali metals smaller size. Okay, the size is smaller, the hydration enthalpy is higher. The size is smaller, the hydration enthalpy is higher. So the hydration enthalpy or hydration energy of alkaline earth metal is higher than alkali metals. Okay, for example, sodium in magnesium. Rewrite sodium 11, magnesium 12. The nuclear charge is increases. Okay, so 281. 281. Magnesium 282. 282. Okay, so the size is smaller. The magnesium size is smaller than sodium. Okay, the smaller size compounds exist in hydration enthalpy than larger size. Okay, so alkaline earth metals is smaller size, so hydration enthalpy is higher than alkali metals. Alkali metals. Then, so sodium loss of 1 electron in Na plus, but magnesium loss of 2 electron. Okay, the loss of 2 electrons, the size is very small. Then the alkali metal ions. Alkali metal ions. Right? And top to bottom, the size is increases. Okay, so the top to bottom size is increases. The hydration enthalpy are also decreases. Beryllium, magnesium, calcium, strontium, barium. Okay, so radium is a radioactivity element. So beryllium, magnesium, calcium, strontium, barium. The hydration energy is decreases. Hydration energy is decreases. The size is increases. The hydration energy is decreases. We write in sodium, okay, magnesium, potassium and calcium. The salts of magnesium chloride exist. The 6 magnesium chloride 6H2O, and salts of calcium exist. Calcium chloride 6H2O, but does not exist in sodium chloride in 6H2O and potassium chloride in 6H2O. Okay, so alkaline earth metals are higher hydration enthalpy than alkaline metals due to size. Okay, so hydration enthalpy. Next, electronegativity. Electronegativity, right? The tendency of the electron attract towards itself. The bonded electron attract towards itself. Okay, in left to right, the size is decreases. The electronegativity value is decreases. So compared to alkali metals and alkaline earth metals, the electronegativity is higher in alkali earth metals than alkali metals. You right? So size is smaller size. So electronegativity, effective nuclear charges increases. The electronegativity value are also increases. But in top to bottom, the size is increases. In down the groove, the electronegativity value is decreases. Okay, the effective nuclear charges decreases. The screening effect is increases. So size are also increases. The electronegativity value is decreases. Right? Next, the flame color. The flame color under the spectra. The flame color under the spectra. Alright, so the salt of alkaline earth metals. The salt of alkaline earth metals moist with hydrochloric acids. The salt of alkaline earth metals moistened with hydrochloric acid in a platinum wire to heated with platinum wire in the flame. Okay, so heated with platinum wire in the flame. The different color is formed. Okay, so the beryllium and magnesium does not exist color. Very smaller size, so does not exist color. Okay, so calcium, okay, calcium, strontium and barium exist different color in different wavelength. Different wavelength. Radium is a radioactivity element. Right? The calcium, brick red. Calcium, brick red. Brick red. Okay, wavelength 622 nanometer. Okay, brick red color. Strontium, crimson red. Crimson red. Okay, the wavelength 689 nanometer. 689 nanometer. In barium, barium apple green. Apple green. Okay, the wavelength 584 nanometer. Wavelength 584 nanometer. You write? So the flame, the heated in the flame exists the valence electron. The valence electron. Okay, so observed energy. The valence electron. So observe heat energy to transfer higher energy level. Okay, this electron to return to actual place. They emit the excess of energy. Okay, so emit the observing energy. Right? In different wavelength, the different wavelength region to give color. In 622 nanometer, the calcium give brick red color. In 689 nanometers, the strontium gives crimson red color. In 584 nanometers, the barium gives apple green color. Are you right? So, characteristics of the general characteristics of alkaline earth metals. You right? Thank you, students. We'll meet next class.